Hello, everyone. Good morning, good afternoon from whichever place you may be joining us. Happy Thursday to all of you. Thank God it's almost Friday. We're almost there. I'm so happy to have you all here. I'm going to be starting this session. Remember that this is going to be recorded, so we're going to be sharing this afterwards through the Google Cloud community. The agenda for today is, as usual, we will walk you through the dynamic of these sessions, what's in with this community that we're talking about, the Marine API community. Then we'll have Nicola walking us through this interesting topic for the topic of the month, that it's JavaScript January. He'll talk with us about API load testing techniques with Apigee. Then we'll go to a Q&A discussions, but remember you can pop your questions throughout the sessions using either the Q&A forum or just raising your hands. And then we'll wrap up this meeting with some updates we have for you. So what I have in here is a bit of an insight of how this community was originated. 𝗟𝗲𝗀𝗶𝗴𝗲 and Jimena, they both organized this community for developers, from developers, so that you all can thrive and have a knowledge sharing space, accelerate adoption, and build a strong community of enthusiasts around the world. So this community used to be just in Madrid, but now we're a global community. So thank you all. If you like, you please help us writing from where you're joining us in the chat so that we can see how diverse this community is becoming. And so the dynamic for this session, as you know, we are going to be having for this time 130-minute presentation from Nicola. Then we'll go over for a Q&A section so that you can ask questions, have an in-depth discussions. And it can be just for the topic that Nicola will be covering, or you can bring some other that you would like to have a discussion in. And so we'll meet almost every Thursday. As you'll know, we'll be skipping some of those who might be holidays, depending on the span that we have to cover these sessions. And well, like I mentioned before, this session is going to be recorded, so we'll share it through the email for those who have registered in the RSVP. But if not, we're also going to share that through the Google Cloud Community event space, or you can find the digest in the forums for Apigee and application integration. Lastly, we'd love to have you joining us in this forum to speak for yourself and talk to the community. So if anyone is interested in joining as a speaker in this session, please reach out to me or reach out to anyone through the Google Cloud community. We'll be happy to talk more into details. So as I mentioned already, you can share your questions through the Q&A. Just look for this icon or just raise your hand and we'll give you the word. Let's just keep a respectful environment and respect each other's words as when they would like to be popping their questions. And without nothing more to say, I would like to introduce you to our speaker for today, Nicola Cardace. Nicola is one of our Google Cloud Technical Solution Consultants within the Apigee Customer Engineer EMEA team. He joined Apigee 2 years ago before the IPO and following acquisition from Google Cloud 8 years ago. So he has a wealth of experience with Apigee deployments in Google Cloud, working in security architecture. Quite an expert we have today. Thank you, Nicola, for joining us. He has this expertise in all industries in EMEA and outside too, and he's also a Google Cloud startup mentor and advisor. So thank you, Nicola, for joining us today. I'll hand it over to you and welcome.
Thank you, Alexandra. Welcome, everybody. Glad to be here. There will be no 2 separate slots, but there will be a single slot. It's a bit longer because the topic is pretty broad. We're going to cover API load testing, or in general, we call it also performance testing, stress testing. I'll tell you the difference in a second. APIs in general, but obviously with Apigee, and Apigee has multiple flavors. It's either Apigee X, so fully managed in Google Cloud, single or multiple regions, where you don't care about scalability because it's managed and monitored for you, or in Apigee Hybrid, where you actually have the same runtime with the control plane in Google Cloud, but you need to manage size and manage and decide scalability and performance KPIs for the runtime wherever you want to deploy, as long as it is a Kubernetes compatible distribution, right? You can do that in other hyperscalers or in OpenShift and so forth. Okay, so in one case it's a black box, the other one is open box. The principle for load testing and I would say the science and the magic and art of performance testing and tuning is In one case, I mean, in both cases it's the same, but in one case it's a black box. In the second case, instead, will be, you need to know what is Apigee runtime, the components, scalability. We look at the horizontal and vertical scalability and all the dimensions and the degrees of freedom that you have. Okay, so we look at both the techniques, the tools, open source tools, how to generate a load test, how to actually iterate, and then we look at the best practices for tuning as well, and the configuring the runtimes in case you need to do it. Okay. You can raise your hand in case you have questions. You don't need to wait till the end. I think we can also make it interactive in this way. I think it should work also more smoothly. Okay, so there may be different degrees of experience that you have been working with or practicing with in regards to generating HTTP, or web performance testing, or API performance and load testing in general. At the project level, and usually this is a step that I recommend strongly not to skip before production go live, okay? Because that's effectively also performance validation. With performance, we usually mean throughput and latency, okay? They're very related, very, very closely related between each other. I will go and tell you a bit more about the agenda. So the first one, as I mentioned, we're going to discuss about performance considerations, helping everybody. There is somebody raising the hand. Yes, go ahead.
Oh, yes, sorry. Felipe is open the microphone, so please you off the microphone.
Okay. Yes, Felipe, please.
Yes, it's in sound.
Okay, fine. Okay, so no questions yet, right? Okay. Okay, I'll continue. Oh, Felipe, unless you have some. Fine, I'll continue the rest. Okay. So we do performance considerations. I'll explain what it is if you've never done anything similar. Then we look into the Apigee specifics. And then we cover more detailed testing approaches. So what type of methodology, the process itself, how to iterate, and why it is important to iterate, okay, and tune. And then the tooling. So I'm going to show you tools that you can actually deploy open source, so that do not require any commercial licenses, to generate volumes testing, and actually to start testing and validate the performance considerations. And then the sizing guidance, in case you're actually dealing with Apigee hybrid runtime, where you need to actually install it, size it, decide the sizing, decide the configuration in terms of both CPU, RAM, networking, storage, for example. And then I'm going to give you a lot of guidance with regards to scaling. So as I mentioned before, scaling is, you have a lot of degrees of freedom. And in general, this is an iteration where basically you need to understand if your capacity, if you're actually managing your own capacity, if it's actually like enough, where is the bottleneck, how to remove the bottleneck, and what to configure in Kubernetes to actually move forward to meet your capacity requirements or latency requirements. Okay, so we'll look into that. I would say pretty much it's a lot of experience here, there's a lot of history. And and we rely on Kubernetes, which is a great product for automating as much as possible and removing headaches. So I'll move to the next slide. So first one, performance considerations. You see, if you recognize the logo, we are talking about big engines, usually expensive, but at the same time they're fashionable. And obviously, like with performance, with a lot of performance comes also great responsibility. Like imagine yourself as a driver, but imagine yourself also somebody needs to take care of the engine and to make sure that everything is tuned. You don't want to forget anything. You don't want to miss, obviously, the fuel, but you don't need to miss oil and other. If you're a great geek, you also want to make sure that you are tweaking everything possible to get the most out of the experience. So for people that have never actually dealt with performance in general, what we define, we try to define normal operation zone and situation where you believe that we consider it as a system is under stress or overloaded. Okay, so these are this is a small simplified two-dimensional chart. You see on the horizontal. Give me a second. I'll give you the also pointer, so it's better to actually visualize. So if you see, this is time, this is system capacity. So I assume I'm actually increasing my request rate because I want to check how much traffic can my system cope with? And this is not only about API gateway. There may be a backend. This may be an API server. This may be a web server. This may be a combination on that. Okay. So imagine I'm actually increasing the runtime, the request rate. There will be a point in which, ideally, as you want to be able over time to increase it as much as possible, as much as you can, simply because you have a, I don't know, large API program or a large number of customers or clients, and you expect this to be linearly increasing without any type of bottleneck or limitation. But the reality is that as soon as you have a scenario where this is increasing constantly, you reach what we call a capacity limit point. So where we actually see that instead of having response rates growing together with the request rates on the same rate, on linear rate, on the same flat rate, you actually you don't see the response rate in increasing again. So usually it comes to a plateau or a flat line that we call in general system capacity. This is overly simplified, but it gives you an idea of what we define as a capacity limit point. From this point on, what is the main difference in the behavior if you look at the black box, right? So before you had a kind of reasonable, acceptable response time for your synchronous API calls. From given point onwards, you see this kind of knee effect. So suddenly you start seeing errors that you did not see before. These errors may be HTTP error codes. There may be timeouts in the clients while waiting for the response, because at the same time you see that the response rate from the server is actually going up on average, or the P99 percentile is actually shooting up till a point in which everything is not acceptable anymore. Okay, so this is overly simplified, and I show you something a bit more realistic. What you don't in general have, you don't have only two zones, like a comfort zone and overload for the system, right? But you'll have also a zone that we consider it as a degradation zone, where things are actually going up, started to go bad. Okay, so you see maybe potentially like some gentle increase in the latency, in the response latency, but it's still technically acceptable. Maybe nobody's complaining about it. The user experience is not disrupted. If it's a B2B API, everything works as expected. There are no timeouts yet. And basically, before getting to the capacity limit point that you saw before, we actually start defining what we call degradation, right? Degradation does not need to be always like a sudden. There may be actually flying behind or below the radar. So you see basically timeouts appear later, the errors appear later, but there will be always a point that we move from degradation, acceptable degradation, I would say, in and around the limit point, to a point in which you totally break concurrency, okay? Because then you start getting errors, and obviously understand that you don't want to operate your system in the overload zone. You want to stay away into degradation zone, and basically, how do you discover where are those points, or how you define those zones? I didn't put numbers here. I didn't put any sizing. I didn't put any times or response times. What is an acceptable latency, and what is a non-acceptable or really, really bad latency? So those depends on the application, depends on the business. But in principle, the idea of having a way to measure these things, or to be able to potentially push the degradation point and the capacity limit points and concurrency limit points as much as possible on the right-hand side of the graph, but also on the top side. So we know that basically we can cope for a long time to a lot of traffic before degrading, before impacting the experience, or before disrupting the experiences or the responses itself. Okay? So it's very simple. So now, in general concept, the only concept that you need to know, if you don't know, if you never use Kubernetes, which is actually if you like, the engine where we actually deploy the runtime for Apigee hybrid, but also where you could deploy your backends or your application middleware, no matter if it's inside Google Cloud, because you have an hyperscaler. So we refer to GKE, so the fully, I would say, Google labeled release of flavor of Kubernetes. So you have another Kubernetes distribution, another hyperscaler, or you go commercial, you have OpenShift on-prem, which is also managed, or bundled Kubernetes compliant version according to CNCF, which is the Kubernetes and the cloud native foundation, right? So you might actually have the same type of features. So what's happening here? If I deploy a cluster in a component, or the application in a component that will manage capacity for me because it can auto scale, we actually need to see when I grow my capacity request rate, so that's the blue line, and I have elasticity in pods to be actually, the pods effectively is an instance of an image for my runtime that is able to actually be added dynamically when the capacity request is being increased. So you see that basically the Kubernetes is able to schedule the execution on new pods to be added to the same cluster. And this can happen at by looking at the request rate, by looking at the latency in the responses and so forth, or by looking at additional advanced metrics like API call rate or API response, total response latency or total processing latency, or even the number of concurrent sockets open to serve within the cluster a given number of clients that are actually invoking APIs. Okay, so what's happening is that Kubernetes will actually decide to actually schedule the new pods, so new instances of the runtime, and then this is not instantaneous. It will take a few seconds for the pods to be actually deployed, and they will start serving traffic. So they will be joining a load balancing group within Apigee ingress, which is effectively is a load balancer within the Kubernetes cluster, no matter if it's X or hybrid. And then basically those pods will start serving traffic. What I will have as a net effect is that the response time or the latency will actually go down. I'm actually going up with the capacity or the request rate. And you see the response rate is actually growing at the same time with the request rate. So no issues in terms of disrupting the traffic. There will be another point if I keep increasing the request rate, where I start seeing again another type of degradation. I can see the response time going up, and that's well before I see errors. But then in this case, what's happening here instead is that I run out of the physical capacity to let the Kubernetes manager or the management plane to schedule new additional pods, simply because pods are effectively taking a chunk of CPU or virtual CPU and RAM. So I physically run out of extra CPU and or RAM. So what I need to do is actually schedule the new node or one or more nodes to be added to the cluster. Okay, so we call this a node auto-scaling, and with node auto-provisioning. So this means that the cluster will need to receive one or more extra nodes instead of pods. And on those nodes, they will be brand new and free. And now the scheduler is able to add additional nodes for the runtime to start serving the ever-increasing capacity. Okay, what is the difference between pod auto-scaling and node auto-scaling is that while the pod is actually being scheduled and executed on an existing node, so it's very fast to run. We're talking about a matter of seconds. For a node instead to be provisioned and added to the network of the cluster, it will take maybe 30 seconds, 1 minute, 2 minutes. So you have to wait a bit more for that. Okay, and then once the node is ready, then the pods will be scheduled, and from that moment on, actually usually you see decreasing response time on average response time, and you see the new capacity has been added. Okay? So that's the type of scenario that on the way up, Kubernetes is managing for you in two different mechanisms. And obviously the auto-scaling also works down. If you don't have a peak in capacity, but it's actually quiet time, imagine a bank which is serving business transactions Monday to Friday, but Saturday and Sunday, this is actually instead, that capacity is not needed because there is no such activity as during the weekdays. Then obviously you want the cluster to recover the empty nodes because they're not necessary and not needed anymore for scheduling, and then basically the traffic has been going down, and you don't want to pay for those nodes. Okay, so you have basically in general a mixed scenario where you have a plateau for traffic and you have some extra variable capacity that potentially you might be paying for in addition. Okay, obviously this is not the case if you have a fixed cluster because it's OpenShift and you have it installed on-prem. And obviously, there's you can actually use the magic for serving the new pods or shuffling the pods, or potentially upgrading them with the runtime, or actually recovering or destroying the faulty ones and replacing them with the healthy ones. So that works both for nodes. So that's a node replacement when the virtual machine gets into an inconsistent state, but also very often for small pods. Okay, but remember, this is actually managed for you. Okay, so effectively, that's the main difference with the VMware. Kubernetes. Okay. Now let's look at try to understand what is the performance validation. Right? Is now you have your own Ferrari. Now you want to actually test drive it in a real circuit. Okay. So what is this? In few words, when we refer to performance tests. Okay. So there might be actually different things. So we need to be super careful with ourselves and are super clear of what are we actually. What is the aim or the success criteria of the test? Okay, so what are we actually effectively validating for? So the one type of test might be a stress test. I just want to increase progressively, as I saw before, the load and trying to understand or discover how much traffic can I cope in terms of API calls per second, in terms of throughput, in terms of payload size and the request and the response. Okay, and I want to see for a given capacity how much can I push. Okay. So the other one is that is a peak load test. So this time instead is actually I just need to validate or meet a specific business objective. Sometimes I don't want to progressively increase. There will be actually a kind of step function. I just want to see, can I cope with 1,000 calls per second? Okay, I just do a load generation test. I will actually start from moment one. The next second you get the traffic of 1,000 calls per second. Let's see what happens to the, is the backend warm and is it able to cope with this step immediately without showing any degradation, any timeout, any error. Okay. The other thing I can do is a spike test. Instead, I can actually do this, but I can do it with to actually check and test immediately the maximum design capacity. This might be actually like impulsive. So I can actually see if I can actually have the system working on a baseline of expected traffic, but at the same time, if I can inject additional traffic without notice, can the system cope without showing error and extra latency with that as well? Okay. And then there is another scenario where I can do soak test. Soak test instead is I know I already validated the performance. I know I can actually cope with a given throughput, but I'm not sure that there is some Java classes that might have, I don't know, imported because I'm actually using an Apigee Java callout policy that allows me to import libraries, but maybe I need to verify that there is no memory leak, for example, in a class. So not the bad code has been deployed as an extension for example, for encryption, decryption, or payload inspection, sophisticated payload manipulation, where, in PCI, for example, you're supposed to encrypt at field level the payment details. So it's not only HTTPS or mutual TLS, but I need to pass to the backend encrypted payload for specific fields or encrypted headers, and I need the bouncy castle or the crypto.js libraries to do that. And I want to make sure that my implementation is not actually leaking memory, because if it leaks memory even slowly, imagine it will actually slowly start using more RAM, but you only found out after a couple of days or after several days that the pods will be starting crashing. Okay, so you really want to make sure that everything is stable for a very long time. Doesn't, it's not enough to say I'm gonna performance test it for half an hour. I think it's good, and I'm gonna run it forever because I got assurance, advanced assurance that everything is. I can assume that that it will work and perform in the same way forever, without any surprise. Okay, that's why soak test is also very important. Okay? That's a more realistic test. Okay. Now I'll give you a framework for actually, and I'm going to give you later also there are like links to documentation and open source tools to actually start creating a testbed environment, end-to-end testbed. Okay. So look, here I have a runtime Apigee environment. So it's a Kubernetes cluster. Obviously, there might be a single region. This might be either hybrid, where you need to install it, or it might be X, where it is managed for you. And then if it's X, you can actually deploy it basically with a single managed API call. You choose the region, you choose analytics region. Backends, you can actually deploy wherever you want in cloud, and we call them SAMPLAN, right? The target backends in cloud or in your private data center on a different cloud provider, or there could be a third-party service somewhere else in the internet. And there could be either the real backends or there could be mocks. There is there is a set of open source applications also in the documentation links that allow you to basically simulate request response of a real application server with without impacting your real backend. You don't want to do tests in production if you're actually handling real customer data or real sensitive production data in your backends, but you can actually simulate them You just need to simulate the interface of the same APIs so that you can actually do the same. For example, you verify the same throughput with the same size of the request, with the same type of verbs, HTTP verbs, and potentially the same type of payload responses. Okay, and you can put a load balancer in front of them. At the same time, you need to create it, or you can create a different Kubernetes cluster dedicated for generating the load that you want to inject and verify the chain, right? So you remember that the API gateway is effectively is a non-transparent reverse proxy. You might actually execute policies, but you are effectively, by doing this testbed, you are testing a chain, API gateway and load balancer and backend or backends. Okay, so effectively that's effectively the full system stack under test is a hybrid or X runtime plus your target backends or the corresponding mocks. So there are two options here, right? Why there is a load balancer and the public front end? Because effectively the tools that I'm actually listing here, either Locust, which is open source, or this Gatling, which is a distributed version of Gatling, which is also an open source load generation tool, are actually available to be deployed in Kubernetes. And they give you an UI where you can, or management UI, where you can control the load generation process itself, and you can actually script complex processes. Load generation does not mean that you are running the same API call for, I don't know, 1,000 calls per second for 30 minutes. But it might also mean that if you have, for example, more complex workflows, when you need to have a client that is using an API key that needs to get a token endpoint /authorize, for example, to retrieve OAuth2 token, and then you need to have millions of those tokens to be tested concurrently against API gateway to be verified before accessing a protected resource. Then you can actually schedule those steps, or you can actually effectively create your workflow script inside the Locust or Gatling to make sure that effectively you are actually sending traffic from or simulating traffic from million different clients, each of them with their own API keys, with their own OAuth2 token that very likely is short-lived, and within a minute they will need to keep, and you run it at, let's say, 10,000 calls per second, and within that throughput, then every minute the token expires, and before expiry, each individual client will actually hit the token refresh endpoint, because OAuth2 protocol allows you to do that. Okay, so you are actually testing not one API, but you are testing a real-life scenario of a very high number of clients concurrently submitting traffic in the same way as you would do when you actually have a production traffic. Okay, so you're not testing somehow simplified scenario. You want to test something very, at least at the same complexity or mixture that you would expect in production. Okay, so that's very important. So you're not testing, in the lab, but you are actually replicating the real life scenario. Okay? So this is an example of response time percentile chart over time, success rate. You see this is coming from Gatling. They give you these charts during the test. You see this test was effectively only 1 minute long. You see what happened in this minute. I have a total number of active users charted in yellow. You see I actually ramped up from 0 to roughly 1,000 concurrent clients. And I got a variable response time in milliseconds from 0 to more than 1 second response time. And the color coding here means a percentile, right? If you look at 99 percentile, the dark ones correspond to what is the maximum, or pretty much the maximum response time that was seen by a fraction of the clients while waiting for the response. So you can see here under peak, after the traffic ramped to roughly more than 200 concurrent users. So some of them actually received the latency responses of more than a second. Okay, so some responses were given more than 1 second late. Some others, so the minimum, the fastest, the best, or the luckiest ones, even under this kind of a small peak of latency, there was no errors, you see. But basically, even it's the lucky ones that, or less than 5% of them, maybe 10% of them, they experience maybe less than, I don't know, 150 milliseconds of latency in their response. Okay, so the bad things happen not to everybody, but to a fraction of unlucky clients, if you like, under stress. Okay, so effectively the distribution percentile chart will help you understand how many clients are actually being impacted by poor perception of latency. This is actually very visual quick way to understand how bad things are going during a test. Okay, so in this case, not very bad, but you see 1 second latency is already a lot if you're dealing with a mobile app. I'll give you some extra examples of toolings. So here we see the disc brakes of the Brembo one, right? So from the Ferrari, these are actually manufactured by a company, and the yellow part is actually this is the disc, and this is the when you actually hit your brakes. This part, this is not moving, but inside it you'll have something that will actually get closer to the brakes, okay, and actually slow down the car. You see, so distributed load testing with Kubernetes, this is what we do. Remember, this is your cluster. I think it's a bit confusing because the ping customer cluster is on top when you run the runtime. It will be XOR hybrid. And load testing in general, coordinator worker, this is in general for guidance, this is a different cluster, right? So you don't want to basically share the same cluster for the runtime and the load testing tools, because otherwise you are actually stealing capacity from the runtime, okay? So it's a suboptimal exercise. What is important is that management plane is not involved in the load testing. You see external client apps are here, but I'm actually testing from a different cluster. I can actually simulate a baseline load with my load testing tool. At the same time, I can actually test real-life scenario for my real-life client applications that are connecting from the public internet, for example. Okay, so I actually hit the runtime with the extra baseline traffic, and I want to see what's happening, what is experienced for the live, for the real production clients under test. Okay, and you do this in general to validate realistic expectations of latency and throughput before going live, for example. Okay, and these are the real backend servers where the target backends. Okay, so I leave you the 2 articles. So the first one is an architecture session. It shows how to actually execute the distributed load testing using GKE. So this is fully within Google Cloud. And then the second one, distributed gathering, you can actually see step by step how to realize the cloud native API load testing. So this means it will help you to deploy the load testing tool, to execute your first testing tool, and actually gather the metrics and the findings. Okay, so if you've never done it, this is actually a pretty guided process. I'll pause for a second if you have any questions, because this might be worth for for small traffic, but also multi-regional traffic. You can actually extend it to global traffic sourcing for global applications, okay, for internet scale APIs or services.
Thank you, Nicola. We have one question from Mohammed. I'll read it aloud to you. Apigee Hybrid only supports standard GKE clusters as far as I know. How can Apigee Hybrid support automatic node scaling?
It's not only it's not only GKE. So the right answer is Apigee Hybrid is designed, certified for compliance with multiple platform versions. So that's a GKE in GCP, but that's actually if you want to use Azure, that's AKS. Then AWS is called EKS. And then we also have OpenShift, and we also have a Rancher. Okay, so back to your question. Effectively, I will cover it later. So how to check scalability, how to tune scalability after installation. Effectively, we rely on standard Kubernetes mechanisms, but that's configuration within Apigee Hybrid runtime. Okay, Apigee Hybrid runtime is installed as a set of images, and via the Helm chart, you can actually tweak every parameter that you want for the configuration. Okay, and remember that node autoscaling and pod autoscaling or horizontal pod autoscaling are features of Kubernetes. So what you have in hyperscalers, you don't have in a private data center, you don't have you have this horizontal node autoscaling. I can keep adding nodes, and I think the current limit for GKE in GCP is 20,000 nodes. Okay, so every cloud provider will have a limit, but this means that you can start small and you can incrementally add nodes and pay for them later only when you need them, right? If you instead have an OpenShift cluster in your private data center, obviously that will come with the physical hardware. You can still extend it, but obviously you need to purchase and install the hardware. Okay, that's the main difference. Okay, is it clear? I mean, it's not only GKE, it's any cloud distribution of Kubernetes that is supported, and you can actually have multiple regions. I can have a dual region GKE plus Azure Kubernetes engine. Okay, and they will work together. Okay, perfect. Any other question? Okay, then I'll progress quickly. Hopefully this is getting interesting, or like, I will leave you here the recommended tools and resources. So the first important article with a deep dive, step by step, if you want to get involved in a project when you're doing performance validation, I'll just go, and this is a community article that I wrote. It's evergreen, I would say. It's methodology, it's a process. It doesn't change if we release new Apigee hybrid features. You don't change the approach for performance validation, performance testing. What you can choose different tools. There are many open source tools. I recommend some. You might want to decide to actually use a mock for your backend because you don't have it ready yet, or you don't want to use a real one for performance testing. So you can actually deploy a mock, and you can basically load the Open API specifications to it, and this mock server will basically impersonate a real backend with real APIs, potentially with the fake data. So every call will actually get, potentially random responses in terms of their payload or customer data and things like that. Okay, so that's very flexible, but they will not. You don't need to be assuming that you need to start performance testing on an API gateway for a target backend. If the backend is not ready, you are not blocked. Okay, as long as the specifications are ready, you can actually simulate it. But simulating it means that you deploy a mock, but the API interaction will be similar or realistic. Okay, there are also tools. I don't think I mentioned it here, but basically it's called the 𝗧𝗲𝘀𝗁𝗶𝗴𝗲 where you can actually impersonate a man-in-the-middle proxy. They will be effectively injecting network problems into the connectivity. So it's a bit like, imagine that you need to simulate what happened, or your business the product owner asks you what happens to the performance of the proxy or the total perception of end-to-end latency or throughput of Apigee gateway when the backend will not be able to cope with the same amount of requests because it's slowing down. It's actually responding with under pressure with, let's say it's a database that you're not able to scale it because you have a budget problems. And it's actually responding with ever increasing total response latency. You can actually simulate that by using a man-in-the-middle proxy called the 𝗧𝗲𝘀𝗁𝗶𝗴𝗲 proxy, where you actually have some configuration variables that will allow you to slow down the response of the mock or the real server by doing man-in-the-middle. Okay, so that's usually powerful because you are actually introducing real, where in 𝗧𝗲𝘀𝗁𝗶𝗴𝗲 proxy terminology is called intoxication, or network intoxication, but effectively means that you are actually testing a real life scenario where life is not perfect, where you can actually have bottlenecks. You might have bottlenecks in the network infrastructure provider. You might have outages or partial outages. You need to see what happens, how the traffic is impacted for that. Okay, so we have also some command line testing tools or benchmarking tools. Those are binaries, single binaries. You can deploy them in clusters, or you can just run standalone from a bash from command line. These are called WRK or WRK2. So there's a change in the behavior of how the traffic is generated. But the important bit is that they're single binaries, but you can cluster them, or you can actually create the bash scripts to. You don't really need bash scripts to coordinate if you want to do more than one. But what you can do, you can actually create a bigger machine. If it's enough to generate for a given number of concurrent sockets, I don't know, you can do maybe even with a pretty fairly medium-sized machine. They're very efficient because they're written in Go and compiled. You can do 10, 20,000 calls per second with a single machine in maybe 1632 cores. Okay, but if you need much more, imagine you say they ask you to test, I don't know, 200,000 calls per second peak. Then you can actually go. You create a small Kubernetes cluster. You install distributed Gatling or locus.io, and I also share with you the how-to article, how to do end-to-end test. It's actually pretty funny. You're not investing a lot of money. This will be costing maybe $20, $50 of credits, but if you want to learn on GCP, you have $300 a trial credit if you don't have an account, and effectively you can generate maybe 5 or 10 minutes worth of large load test end-to-end. So you learn everything. Okay, obviously this is not enough for a soak test of several days. But then at the same time, I give you the articles for what to monitor in Apigee in terms of APIs. So we have metrics exposed and alarms and alerts for not only the response code, but also the latency, end-to-end latency of the invocation to the backend, connectivity latency, or socket connection time. And also you can actually get the granular metrics with regards to every single API proxy in every single environment. request latency, response latency, and even you can go down to the proxy single policy execution time. Because if you're trying to troubleshoot, as I told you before, for example, a large Java class, and you suspect that class is actually taking several milliseconds, or let's say 200, 300 milliseconds to execute simply because of its complexity, and you want to optimize it, then you can actually get down to the individual latency analysis of the single steps, okay, or the single policies being executed. And then the idea of the performance testing and tuning is that you need to gather. So first of all, you actually source the traffic. You find a way to generate the traffic you want in the shape you want. But then after that, you need to understand that you are actually trying to move one bottleneck away to grow traffic throughput and reduce latency every time. Okay, and then you iterate. So you identify a bottleneck and you move the configuration, you change the configuration, you test again. Okay, so I'll show you this performance tuning possible dimensions. So we already saw the Kubernetes cluster sizing. So you start with an initial assumption, because it's basically the one that you think, or the customer engineers would have helped you to say the sizing. Remember, this is not true. You don't need to do this with Apigee because it's fully managed. But for your installations, you choose the cluster sizing, you choose the number of nodes, you choose the type of nodes, how much RAM and how much CPU, because that's basically down to your budget. And you define the resource limits in terms of minimum and maximum. For a horizontal pod auto scaling, you choose the behavior, and you put either CPU threshold, but we also put now additional dance metrics. So I can decide to auto scale because I see an extreme increase in the end-to-end latency, even if CPU is low, simply because some of the threads might be higher weights. So the CPU is not really busy, but it's actually waiting for a response from slow backends. In this case, I also they will not hit per se the CPU utilization threshold, but basically those threads are actually at the higher weight state. They cannot be, piggybacked by other API calls, because they need to be ready when the response comes back to resume and process the response. Okay, so you see now you start having contention between the real life scenarios where you think you have enough capacity, but in reality, most of the capacity is actually booked or busy while waiting for responses. So now you got a point of, the response or latency times being impacting the overall capacity or peak capacity of your system, not because everything is busy, but because everything is actually waiting for a response, and they cannot be double booked. Okay, so that's how it works. Threshold and scheduled events. So now we can actually do this. Imagine you have a predictable capacity, 9 to 6 p.m., 9 a.m., 6 p.m. You don't want to pay for capacity augmentation or additional capacity during night times, during times in which you don't have such a peaks, and then you can actually decide to have an automatic reduction of the cluster itself. Okay, so remember, with Apigee, this is done and managed for you automatically. You don't need to take care of it. If you do hybrid, you need to actually choose the strategy in general. Okay, now we also do, so this is actually, we updated this. Now we can actually use the latency and even the total open socket count while waiting for the responses. Then those are also taken account into the auto scaling up and down decisions at the moment. Okay, I'll pause for a second. There's a lot of new concepts here in the traffic engineering. So I'll wait if you have additional questions on this.
Thanks again, Nicola. We've got another question. How can you address back pressure issues with the backend system?
Okay, so obviously you are under the assumption that's a good point, because I think I mentioned that to you, right? So you're under the assumption that you don't want to basically modify the backend. What we currently do with this open sock count utilization monitoring, you can decide to actually increase the total number of runtime pods to simplify or to remove load from the Apigee gateway, even in scenarios where the backends are slow. So that's only from traffic engineering point of view. Then there are additional strategies that we use in the product. Remember that we have a very sophisticated level 1 and level 2 caching strategies and dedicated out-of-the-box policy. What I mean with level 1, I mean in memory. What I mean with level 2 is a NoSQL database backed cache, and I can have actually even a fully response cache for an API they can be stored on Cassandra. That's actually the NoSQL database that we use for caching, which is replicated potentially also across multiple regions. But what is important is an IETF compliant cache. So we actually honor per object the response cache HTTP headers. So E tag and not valid before, not valid after, and the cache invalidation mechanisms, all the ones that are actually standard, even the most sophisticated. So in general, if you think you have a problem with the bottleneck in the backend, and you know your data that APIs have been served are actually slowly changing. Slowly changing means, let's say, a few times a day, but also maybe in a high throughput scenario, even if they're changing only once a minute, and you're running at 10,000 calls per second, for example, you're already talking to more than 500,000 calls for each individual object that can potentially be served under in a single millisecond from the local Cassandra cache inside the cluster without hitting the backend. Okay, so you see a lot of benefits. So in general, when you have a lot of back pressure, the first thing you do is actually look how much I need, how quickly is the data changing, how much data can I actually move, where the API, where does it make sense to have APIs leveraging L1 and most importantly L2 caches in Cassandra, okay? Because that usually is a very, very, very quick way to actually get a lot of benefits. So you reduce network utilization, you reduce backend utilization, and you actually reduce massively the latency, perceived latency from the clients. Obviously, only when data is cacheable, right? But that could be, you choose your frequency, right? That could be every minute, that could be every hour, or that could be every day. But depends on you know what type of data it is. You know, if it's a product pricing or is it some slowly or fastly changing information. But in any case, you see, don't underestimate it, because even if you have a very high throughput, even if you cache for a single minute, you can actually achieve dramatic changes. You know, you're talking about maybe 50 times less utilization of a backend. And you know, we also in the dashboard, analytics dashboard, the Apigee control plane will also show you what is the most important KPI here is the cache hit rate per individual cache keys, per individual object, per individual environment, per individual API. Okay, so you can actually browse and discover very quickly what are the other dimensions for you to tune. Okay, so any other questions on this? This is actually pretty important. We leverage a lot. All our customers leverage a lot wherever possible caching. Okay. This is even for you know, for legacy backends that were not designed to actually serve caches, and you don't need to, you know, once you have the API management layer in the middle, you don't even need to think about additional third-party caches. Okay. We also have within the cluster Redis, but Redis is not used for L1 cache. It's only used for quota and traffic throttling counters, because they're actually being counted very, very fastly from in-memory counters within the Redis pods. Okay, that's usually like a few milliseconds maximum latency. So the runtime message processor within a few milliseconds will be able to say if your specific client is actually exceeding his allocated quota. And quota could be per second, per minute, per hour, per day, or per week. Okay, for example, because a quota usually is connected to a lot API traffic licenses. You know, B2B relationships, B2B limits to be enforced from a contractual point of view, or technical limits like you know, like traffic spike arrest, for example. Okay, spike arrest is really like you want to protect your systems or backends from abuse or for excessive abuse, and then effectively that's also like some other ways to actually remove back pressure. Okay. Other questions? Otherwise, I'll show you sizing, some guidance on sizing. So sizing, we actually always, as I told you before, X, you don't worry about it. It's fully managed, hybrid. We actually publish the minimum cluster sizing for both development and non-production. For production, usually we want to help you to actually get the best bang from the buck. So we actually point you to the cluster overview, and then basically with the partner manager or customer engineer, usually they will be able to guide you according to the best scenario, to the type of complexity of the policies that you want to implement, to the type of load, to the network topology, the regions, and try to minimize obviously the cost. Okay, or actually tune the pod autoscalers and node autoscalers. Okay. Then horizontal pod autoscaler, now you know how it works. It actually creates this concept of replica counts and deployments, and can actually work for you magically. Okay. So, and remember that each environment can actually have a different configuration. Okay, so if you want to partition traffic and let them behave differently, for example, if you want them to be more or less aggressive with the CPU utilization threshold, then you can do that. And then you can actually do, you can actually add the multiple pods. The calculation is always a desired value for the replicas. It's a ceiling for the product between the current number of replicas and the ratio between a given metric value and the desired. So if I need to add more, it doesn't mean that this formula will always add one more if I need capacity. I might actually decide to add several pods or tens of pods in one go within a matter of few seconds if there is a big change in the traffic profile. Okay? So now this is a very quick, this is also from our documentation, it's a very quick guidance. So what is important part, Cassandra is deployed as a data store, it's a database, so it's a stateful set. You cannot just destroy or assume that you can create pods dynamically with a horizontal pod autoscaler, because you need to attach new pods with a persistent volume, so that disk attached to it. Okay, all others can actually are managed by horizontal pod autoscaler, but not all of them, because some of them you don't need to, because they're already like piggybacking on multiplexing, as we say. So, and they are shipping logs with the daemon sets. It's a type of deployment in Kubernetes, but this means you don't need to let them grow linearly. You know, some of them are actually concurrently helping all other pods. Okay. So how you scale the runtime, you can actually change configuration from minimum maximum. This is for Mart. This is for runtime. Maybe work for other components inside the cluster. How does it work? You actually change in overrides. You apply the change. And basically, if I want to move from 10 to 15 minimum pods for the runtime, I change 15. I edit the file, I put 15, I apply it. And then Kubernetes for me will create 5 new replicas for the pod. Okay. The same for the months. And then scaling up for Cassandra, you can actually have two approaches here, either horizontally. So this means I want to move from 3 to 6. And the Cassandra architecture guarantees a linear scalability. Or otherwise, vertically, I need just a different node pool. So you see here, I have a node selector required for scheduling true. And then I give another name for the Apigee data. And I actually change CPU and memory. And what the Kubernetes will do slowly, it will replace the old nodes with the new nodes, attaching the same volumes, so the data is not being destroyed, with the new specs. Okay, that's how it works. And then I have a guarantee that I will have, in a matter of few seconds or minutes, I will have bigger database nodes instead of the previous ones. Okay, and you can do up or down as well. Yes, Alex.
Just friendly note, we have 5 minutes left. Thank you.
Yes, yes. Okay. Any other questions so far?
Not at the moment.
Okay, so this is everything from our documentation. Okay, so these are playbooks for letting you scale up and down. And you can decide as administrator what needs to be done automatically and what needs to be done, for example, during, I don't need to do horizontal scalability for Cassandra every day, but maybe if your API program doubles after 6 months and you know that it's time to move from 3 to 6, then you can look at the playbook, or potentially for production, you can actually involve our support. They will point you to the right public playbook, and then it will. It's a guarantee to be done with zero downtime, and Kubernetes will do it for you. Okay? Same for down, so you can actually time them for time of day or day of week. And then this is what we do for the sizing checklist: bill of material, node sizing, the settings in auto scaling. Those are the ones that need to be validated with performance testing and tuning. The sizing for the Cassandra database, and then obviously the PVC, which is persistent volume claim, so the underlying disk for type and sizing. How much cache do you use? How much proxies? How much API keys? How much or how many millions of tokens are you managing at the same time? How aggressively are you purging and compacting the database? And then obviously there is a corresponding monitoring checklist for infrastructure in case you run it yourself. Self-study, I leave you this is the last slide. I leave you the links for additional documentation. You can actually deploy a cluster. You could deploy a private HTTP bean server as a mock. And then you create a pass-through proxy. You execute performance test traffic with the tools I showed you before, locus or Gatling. Then you can inject enough traffic to trigger auto-scaling. And you can see what's happening during the auto-scaling events, both for the pods and for the nodes. And then you can iterate until you're happy with throughput and latency. Okay. I think I've leave everything here. There is some implementation specifics here, but these are more like, tips and tricks to how to basically configure the policies in Apigee or optimize for performance and minimize for latency. Okay, so that's all from my side. I hope it was actually helpful and you learned something new and exciting today. Alex, back to you.
Thanks so much. Everyone, thank you so much for joining us in this session. We have this space open for you. Do you have any questions? Raise your hand, share them in the chat or in the Q&A space. We still have 2 more minutes to have a discussion, so we'll wait for you.
Super important if you're working with the projects, either during the planning phase or production go live or performance testing, anywhere in the world you are, you can actually reach out to us and we will be able to help you. Okay?
Alrighty, so I see no questions in the Q&A, not in the chat, so I guess we can start to wrap up. But just like Nicola said, remember, we have both the Apigee and application integration forums in the Google Cloud community, so you can reach out to us through that channel. And I already leave to you the link to our feedback, which is completely anonymous. We will benefit so much from the insights you can share for this session so that we can better tailor them to your needs and your desires. So please take a moment to answer this short and anonymous survey. And we have the updates for the latest articles. You can go and take a look at the product articles section within the Google Cloud community. Judy wrote this article on augmented API management with platform engineering. You can find this version in Spanish and in English. We got also Carlos writing about how to enable and analyze execution logs in cloud logging for application integration. Take a look at this one as well. And as a matter of relating and how these two technologies combine and do a powerful synergy for enterprise integration, app integration, and Apigee, take a look at this article by Simon. And lastly, check this out, this customer success story by Woolworths on New Zealand and how they enhance the loyalty program with API management using Apigee X. So take a look at this article within the product article section of the Google Cloud community. And lastly, remember our resources that we have for you in the Google Cloud community. You can find the forum, the section for events and announcement that we have for you. The upcoming event we have next week, it's not going to be a regular tech talk and discussion of office hours. We're going to be having Christopher Chine joining us. He's a customer engineer in Apigee and application integration, and he'll give us an Apigee and AI update for the 2025. So we look forward to seeing you soon, and back at the first week of February, we resume our regular tech talk and office hours. So that's it from our side, everyone. Thank you so much. And again, thank you so much to you, Nicola, for this amazing and enlightening session.
You're welcome. Thank you, everybody, for attending.
Thank you. Any follow-up questions? We hope to see you in the Google Cloud community. Have a nice weekend in advance. See you soon.